Good afternoon,
Yes.
all. I'm Dr. Rajiv Sharma. I'm welcoming Dr. Manmohan Singh, who is the session chair of this particular session. Dr. Manmohan Singh Chauhan is working as assistant professor in Amity University, Rajasthan. He has more than 8 years of research and teaching experiences. He is doing research in the field of organocatalysis, green chemistry, water technology, waste utilization, nanotechnology, and etc. He invited as a resource person in central government body and also delivered talk in the national as well as international conferences. He has published more than 10 research papers in international rapid journal with good impact factors and also filed 2 patents. He has contributed 6 chapters in EPG Pathshala. He also completed a research project which is funded by DRDO. Welcome, sir, for this particular session. Manmohan sir, please.
Thank you so much for your introduction. And can you start the session?
For the session purpose, I would like to tell Ankita will be on first number. So Ankita, are you ready with your presentation?
Yes, ma'am.
Okay. So share your screen, Ankita.
Is it visible, ma'am?
Yes, Ankita, is it beautiful?
Okay, good afternoon, Manmohan sir and teachers. I am presenting my abstract, Green and Sustainable Method of Water Purification with Carbon Dots, a review. Now in introduction, carbon dots are the new member of carbon family. I am audible, ma'am?
Yes, Ankita, you are audible. Please continue.
Okay. Carbon dots are the new member of carbon family having a size less than 10 nanometer and attracted researchers because of their unique characteristics such as inexpensive and facile synthesis method, easy surface modification, excellent photoluminescence, outstanding water solubility, and low toxicity. Carbon quantum dots are just quantum dots. Carbon dots are small nanoparticles, generally 10 nanometer, that are water soluble, highly photoluminescent, inexpensive to mark, have good bioincompatibility, and are known to be non-toxic. Carbon dots derived from green and sustainable materials are essential aspects of biology, chemistry, and physical sciences with essential application in computer science and electronics. This sets them apart from traditional quantum dots are nanoparticles with diameter ranging from 1 to 10 nanometer. When compared to carbon dots, quantum dots are toxic and expensive. Quantum dots are conventional fluorescent dyes that have unique optical properties and make them a promising candidate of numerous exciting applications. Synthesis of carbon dots. Carbon dots can be synthesized from different materials. There are 2 basic approaches of synthesis of carbon dots, which generally referred to as the top-down or bottom-down approaches. In a top-down approaches, larger carbon structures such as graphite or carbon nanotubes are break down to form a carbon dots, presenting by diagrammatic representation also. In contrast, the bottom-up approach, carbon dots formed from small organic molecules by carbonization of material, example citric acid. These are often synthesized using hydrothermal or microwave-assisted method. It may also help avoid undesirable side reaction, and thus it is the method of choice. The fluorescence of carbon dots can be enhanced if citric acid is mixed with small molecules containing amino group. Applications of carbon dots. Carbon dots have great potential for removal of heavy metal from water because of their large surface area, nanoscale size, and availability of different functionalities, and they are easier to be chemically modified and recycled. Carbon dots has been growing interested in bioimagining of cell and tissue of different living system for in vivo and in vitro biomedical applications, owning of the excellent biocompatibility, small size, and multicolored fluorescence property of carbon dots. In vivo imagining of plant cells is more complicated in comparison with animal cells can done through carbon dots. They can drug-loaded carbon dots can directly pass the cell wall, owning their small size of a few nanometers are released their carried drug of the specific side with pH and photothermal trigger, the provider image to determine. Thank you, sir.
Thank you, Ankita. It was a wonderful presentation. Now I would like to ask Manmohan sir if he have any comment or suggestion, or Rajiv sir if he is present here.
Yeah, definitely. The presentation was very good, and you represented our work like carbon dots for the purification of water. Okay, but just of application of carbon dot, which can be said by you in your poster, like the catalysis reaction and biomedical reaction, particular biomedical purpose, which application can be resolved by the carbon dots. Okay, you can show in your poster. And my query is that after completion of experiment or applications of carbon dots, what about the nanotoxicity? There is any particular experimental procedure to remove the nanotoxicity? Sangeeta, am I audible? Sangeeta? Okay.
Ankita, are you able to hear?
Yes, ma'am.
So can you answer questions?
मैम सर का एक्चुअली वॉइस थोड़ा सा प्रॉब्लम कर रहा है.
Sir was asking what will be the toxicity of carbon dot for the environment if we prepare this and we'll use in green and sustainable water purification, then what will be the toxicity?
Treatment of heavy metal from the wastewater, general aspect, and not deep knowledge about.
Okay, no problem. Okay, thank you so much. Rajiv sir, would you like to ask any question?
No, I don't have any specific question.
Oh, okay, sir. Thank you. If any candidate want to ask question, he or she can ask. Okay, I think there will be no question. Thank you, Ankita.
Thank you, ma'am.
Okay. Now I would like to invite Ayushi for the presentation. Ayushi?
Yes, ma'am.
Okay, fine. Share your screen, Ayushi.
1 minute. मैम स्क्रीन विजिबल है?
Yes, Ayushi ma'am, it is visible.
Good afternoon, everyone. I am Ayushi from Dr. Hari Singh Gaur University, working under the supervision of Dr. Ratnesh Das. Today, the topic of my presentation is synthesis and electrochemical studies of spiroxyindole derivative using efficient and recoverable nanocatalysts. The objective These are the content of my presentation. The objective of my work is to synthesize a spiroxyindole derivative using recoverable and greener nanocatalysts, and these synthesized spiroxyindole derivatives are also electroactive, and their electrochemical study is done by cyclic voltammetry. I have synthesized spiroxyindole derivative using multi-component reaction. Multi-component reactions are new simple and efficient methodology to produce biological active compound and has become important area of research in organic combinatorial and medicinal chemistry. These spiroxyindole systems are core structure of many pharmacological agents and natural alkaloids. Spiroxyindole derivative attracts much interest in synthetic and medicinal chemistry as well. These heterogeneous catalysts I have used in the synthesis, they have much advantage such as insolubility in organic or as well in water. So they are easy to remove from the solvent from the reaction mixtures. For the synthesis of spiroxyindole derivative, I have used active methylene group melanonitrile and 1,3-diketone and isatine. Material and the electrochemical study of synthesized compound is I have done using carbon paste electrode. The carbon paste electrode of synthesized compound is prepared by graphite powder and paraffin bags in 7:1. When I want to modify the my carbon paste electrode with my sample, so I have put a minimum amount of my sample carbon, afterwards graphite powder and paraffin wax. Then I have produced carbon paste electrode so that I can use this carbon paste electrode as a working electrode. This electrochemical workstation I have used for the electrochemical study of synthesized compound. In experimental section, I have used isatine, melanonitrile, and acetyl acetone, which is 1,3-diketone, in equimolar amount and 0.3 millimole of catalyst in a round bottom flask, and stir and reflux at room temperature. And the reaction progress was checked by the TLC, and the crude product was then separated out, and it was rinsed with water. This is the scheme of the reaction. For the synthesis of catalyst, I have used as a precursor zinc acetate and zinc acetate as a precursor, and with this zinc acetate solution is combined with the dextrose solution in 280 in a conventional synthesis, and this solution was prepared with this solution was diluted with water, and after the vigorous stirring, this solution become very hazy. So afterwards this solution was calcinated at 250 degrees centigrade in Muffle furnace. This is the FTIR spectrum of synthesized spiroxyindole derivative, in which we can see the characteristic peak of the synthesized compound. This is the XRD spectra of synthesized ZNO nanoparticles, which I have used as a catalyst, and these peaks show the clearly synthesis of ZNO nanoparticles. These are the same images and EDX analysis of the synthesized ZNO nanoparticles. For the electrochemical study of compound, I have used cyclic voltammetry technique for the electrochemical study. It is an electrochemical technique which measures the current that develops in an electrochemical cell under the condition where voltage is in excess of predicted by the Nernst equation. This for cyclic voltammetry, the solution was prepared by combining potassium ferrocyanide in KCl solution, which act as supporting electrolyte, and buffer solution. Phosphate buffer used as a buffer solution to maintain the pH of the solution. For electrochemical study, I have used carbon paste electrode as a working electrode and modified carbon paste electrode, which was modified with the sample as a working electrode. AgAgCl is a reference electrode, and platinum wire is a counter electrode. This is the cyclic voltagram for the stock solution or for the determination of the surface area of the electrode. These are the cyclic voltagram of my compound, which have been synthesized at different scan rate, and the carbon paste electrode was the working electrode. The spiroxyindole derivative shows two peaks, each have one electron reduction. The anodic half cycle and cathodic half cycle shows one peak as mentioned in the previous figure. The shift of cathodic peak potential towards the more positive value with increase in scan rate indicates the irreversibility of this reaction. Peak current of irreversible system is given by the Randle-Seaways equation. The electrochemical study of this compound revealed that the product is electroactive and undergo oxidation and reduction process at carbon paste electrode. The various cathodic potential value, cathodic current value, and anodic current value and anodic potential value is shown in this table at different scan rate. We have reported therein an efficient green and general method for the synthesis of spiroxide indole derivative in ethanol, and the electrochemical study of these compounds is also done by the cyclic voltammetry. This electrochemical study shows that these compounds are electroactive. This process opens an efficient and convenient multi-component method to create substituted spiroxyindole, the pharmacological active substance with well-known asymptotic, diuretic, anticoagulant, anti-cancer activity and promising compound for the different biomedical applications. So these compound can also be show such kind of medicinal activities. The present methodology shows the mild reaction condition, operational simplicity, cost effectiveness, environmentally friendly ways for the synthesis. Large scale industrial synthesis can also be done by this process. Since it is important to find an simple, inexpensive, recoverable, and reusable catalyst for the synthesis of organic compounds, so this method offers a good yield of products. Products are also electroactive, and the present method does not involve any hazardous organic solvent, so this procedure could be classified within the green chemistry. I would like to thank Dr. Hari Singh Gaur University and my PhD supervisor, Professor Ratnesh Das, for guidance and support. These are the references. Thank you.
Thank you so much, Ayushi. It was a good presentation though. So I would like to ask Manmohan sir if they have any comment.
Yeah, really, it was very good presentation and new findings from nanocatalyst for the preparation of spiroxyindole. Okay, I have a question. Did you perform this preparation with other nanocatalysts like copper oxide, nickel oxide, and platinum nanoparticles?
No sir, अभी तक मैंने सिर्फ जिंक ऑक्साइड के साथ ही किया है, बट अदर नैनो पार्टिकल्स के साथ भी करने का प्लान है.
Yeah, you should definitely check because sometimes we maybe observe new findings in other nanocatalysts. Okay.
Yes sir, surely in future I will done with other nanoparticles.
Okay.
If anyone want to ask any question, they can ask. I can see Renu ma'am is here. If she want to ask any question, ma'am, do you have any question? Okay, fine. There will be no question. Moving forward, I would like to invite Renu for the presentation. Renu?
Yes, ma'am.
Okay. Share your screen, Renu.
Okay. Neelam, is my screen visible?
Yes, Renu, it is visible. I think it is visible to all.
Good evening, everyone. Myself Renu, and I am going to present my work on synthesis of 2-nitro-1-phenyl ethanol and their derivative by Haney reaction using recyclable biocatalyst under Dr. Manmohan Singh Chauhan. These are the contents of my presentation. These are the objectives to prepare the 2-nitro-1-phenyl ethanol by using Haney reaction, to prepare the recyclable catalyst, prepare eco-friendly high efficient catalyst for Haney reaction, and last is to reduce the catalytic reaction time and improve the yield of the catalytic products. Now move to introduction of Haney reaction. The Haney reaction is reported in 1895 by Lewis Henry. It is a carbon-carbon bond formation. It is the combination of nitroalkane and an aldehyde or ketone in presence of base. This is the limitation of Haney reaction. And during the Haney reaction, it is possible that formation of side product, toxicity, catalyst recoverability and reusability, low yield, high reaction time, and high cost. This is the schematic representation of Haney reaction. Haney reaction between benzaldehyde and nitromethane in presence of catalyst. It could be base or acid. Desired product is 2-nitro-1-phenyl ethanol and removal of water. This is the introduction of quinupil. It is basically used to make commercial products such as fresh juice, dehydrated citric products. It contains a variety of bioactive compounds and essential oils including polyphenols, pectin, and antioxidants. After the juice extraction and use of the fruit, about 50 to 60% of the leftover fruit piece discarded as a citrus waste. None method are fully dispose the fruit waste. If waste does not get managed, it may become a major problem. This trash still contains a significant amount of bioactive chemical that pollute the environment. So to expose the wide application of quinupil in the field of catalysis, we have planned the catalytic Haney reaction by quinupil. Move to next slide. These are the results. This is the IS spectrum of desired product. As you can see, the peak of 3329 to 2863, which is correspond to the OH stretching, which shows that desired product contains OH group. This is the IS spectrum of fresh quinupil powder and recoverable quinupil powder. They both show almost same peaks, such as 3310 and 33112 broad peaks in the high frequency area attributed to the stretching mode of the OH bond, which reveals that the presence of hydroxyl group in the both quinupil powder. The bond observed at 1737 and 1738 are assigned to the carboxyl group in the both catalyst. This is the conclusion. We have utilized the citrus waste as a catalyst in Haney reaction to obtain beta nitroalcohol and their derivative with 80% yield in neat condition by using benzaldehyde and nitromethane, which are useful synthons in organic synthesis. Thank you.
Thank you, Renu. Sir, if you have any question, please ask.
Renu, it's very green presentation. Tell me one thing, that what is the particle size of quinupil powder? About the nanoparticle or more than nanoparticle?
Sir, it was firstly it was not nanoparticle or
Fully.
hello.
Yeah.
Yes, sir. It was not nanoparticle. It is just a fruit peel powder.
Okay. Did you confirm from Sam?
No, sir.
Okay, thank you so much, sir, and Renu.
Neelam, I have one question for Renu.
Okay, sir, you are here. So,
Renu,
Rajiv sir having question?
Yes, sir.
Renu, you have talked about the biocatalyst and recyclable biocatalyst.
Yes, sir.
What is the actual meaning of the recyclable biocatalyst?
सर एक बार हमने वो कैटलिस्ट एक रिएक्शन में यूज़ कर चुके हैं, फिर उसको हम अप टू 6 to 7 साइकिल हम उसको यूज़ कर सकते हैं.
What do you mean by the catalyst?
So catalyst which speed up the reaction without involving into it.
It's
Reaction.
always speed up the reaction,
No sir.
or it's
Sometimes
alter the reaction?
No sir, it does not involve in the reaction. Sometimes it improve the yield of the reaction. Sometimes it speed up the reaction.
How it's taking part in the reaction without getting involved? This is my question.
Okay sir.
You are
sir,
saying the
ये-
catalyst could alter the rate of reaction either in positive manner or in negative manner. It could enhance or it could decrease.
Sir, it enhance the reactivity of the reactant.
कैसे? You got my question?
Yes sir.
If you know the question, then only the recycling of the catalyst will come into the picture. You are having some sites for the purpose of reaction. Catalyst generally provides the site for the purpose of reaction. And once those sites are blocked,
Yes sir.
you need to regenerate it.
Yes sir.
And the regeneration would be called the recycling of the catalyst. Okay. Once your sites are blocked, what are the methods you apply to regenerate it? Do you have any study likewise?
No sir.
I think you should go for that because you are talking about the reusable catalyst.
Sure sir, sure.
Okay.
Thank
That's
you
all
all.
from my side.
Thank you so much, sir, for the information and the question. So I would like to, Suren, please withdraw your screen. Yeah. So I would like to ask Sachin sir if he is ready for the presentation purpose. Sachin sir, are you here?
Yeah,
Oh, okay, sir. Share your screen.
just a second. Hold.
Yes.
Is the screen visible? Hello.
Yes, sir.
Hello?
It is visible. Yes, sir. Yes, sir.
Good evening, everyone. This is Sachin Mansal, research scholar in Department of Chemical Engineering. Today, I am here to present presentation on utilization of agro waste raw material for wastewater treatment application, which is a review. These are the outlines. That is the introduction, literature review, parameter studied, isotherm study, kinetic study, thermodynamic study, conclusion, and references. Introduction. In the 21st century, humanity is facing lots of problems related to water quality as well as quantity, and due to the deterioration of water quality and quality is due to the rapid industrialization, urbanization, poor management of waste, which could lead to a widespread environmental pollution, and significant variation in the characteristics of wastewater released from industries such as ink, dyeing and printing industry, pulp and paper, pharmaceutical, cosmetics, food, and many more, which is depend upon the types of raw material they are used, concentration of the chemical they are used, and the most important is what is the processing conditions, like temperature, pressure, they are following during their process. Highly toxic pollutants are present in wastewater such as dye, pesticides, surfactants, and many more. What is a dye? A dye is a natural or synthetic substance that is used to add the color or to change the color of some material. Such substance with considerable coloring capacity are widely used in the production of consumer products, including paint, textile, printing, pharmaceutical, food, cosmetics, photographic and paper industries. And the dye can adhere to compatible surface by solution or by forming the covalent bond or complex with salts, or by metal, or by physical adsorption, or by the mechanical retentions. It is estimated that over 10,000 different dyes and pigments are used industrially, and over 7 into 10⁵ tons of synthetic dyes are annually produced worldwide. In the textile industries, up to 2 lakh tons of these dyes are lost due to in effluent every year. From the dyeing and finishing operations. The textile industry is one of the largest sector globally and produced and extinguished 60 billion kilograms of fabric annually, using up to 9 trillion gallons of water. These are the harmful effects of dye. Most of the dye is kept conventionally wastewater treatment process and processed in environment as a result of their high stability to light, temperature, water, detergent, chemical, soaps, and other parameters such as bleach and perception. Dyes can remain in the environment for extended period because of high thermal and photostability to resist biodegradation. Major environmental deterioration and toxic effect to humans occur. Such effects include cell mutation, skin irritation, enzyme allergy, as well as carcinogenic effects or carcinogenic effects. Various wastewater treatment techniques. The purpose of wastewater treatment is to remove the contaminants from the water so that the treated water can meet acceptable quality standard. Quality standard usually depends on whether the water will be reused or discharged into a receiving streams. A number of different techniques have been adopted, such as ion exchange, adsorption, electrocoagulation, reverse osmosis, advanced oxidation, membrane separation, etc. Among them, adsorption technique was found to be more efficient as compared to other due to its cost effectiveness and better usability. This is the reason for adsorption. This is economical, easily available, ease of operation, less initial cost, flexibility and simplicity of design, insensitive to toxic pollutants, and no formation of harmful substance. From the literature, I studied that a number of adsorbent material are used to treat the methylene blue dye, and these are the adsorption capacity that is in milligram per gram. The adsorption capacity and the dye removal were calculated using the following equations. These are the equations which are used. The batch adsorption process is carried out where the number of experiments are carried out in a constant volume batches. Samples are taken out after a particular time interval, and equilibrium is reached after a certain point of time. And these are the factors that affect the adsorption process, like effect of contact time, effect of dye concentration, effect of adsorbent amount, effect of pH, effect of temperature. From the literature, I find that these are the parameters that affect the adsorption processes. If the contact time is less, dye removal is less. If the contact time is more, dye removal is more, and after a particular time, the adsorption process achieved to a steady state value or a equilibrium value. Adsorption equilibrium: if the adsorbent and adsorbate are contact long enough, an equilibrium will be established, and this equilibrium relation will be established by the adsorption isotherm. These are the various isotherms. The isotherm present how the adsorption molecule distribute between the liquid phase and the solid phase. These are Langmuir isotherm, Freundlich isotherm, Tamkin isotherm, DR isotherm. These are the empirical correlations to find out the adsorption capacities. After that, the batch adsorption kinetics. Various kinetic models are used to validate the experimental result and to determine the process of adsorption. Pseudo first order, pseudo second order, intraparticle diffusion, Illovich kinetic models, and same like adsorption isotherms. These are the relations for various kinetic models. For thermodynamic study, we use these relations to find out the various thermodynamic properties, that is change in Gibbs free energy, change in enthalpy, change in entropy. These are the references. Thank you.
Thank you so much, sir. It was a wonderful presentation. So I would like to ask Manmohan sir or Rajiv sir if they are having any question, they can ask one by one. Manmohan sir, do you have?
Hello.
Am I audible?
Yes, sir, you are audible.
Okay.
Sir, but your voice is cracking in between. Hello. Hello. Hello.
Sir
Am I
might
audible?
having any issue. Sorry, sir. Sir might having any issue in networking. So, sir, I would like to ask Rajiv sir if they are having any question.
No, I don't have any specific question.
Oh, okay, sir. Thank you so much. Thank you so much, Sachin sir, for your
Thank
presentation. So, thank you so much.
Neelam, is all presentations done?
Yes, sir. Yes, sir. Oh, sorry, sir. Technical fault. So all presentation has been done, sir.
Okay.
Thank you so much all for your valuable time, and all the presentation was very informative. And I would like to say now we are about to end our presentation for the day 1, track session 2. So it will be a conference will be held on 5 to 7. If anyone you were interested in the conference speaking keynote speaking sessions, so they can join by the link provided on the WhatsApp, or if you are having any issue, they can contact me or anyone. Thank you. It was a great session. So Rajiv sir, would you like to say something?
Thanks, Manmohan sir, for coming and chairing the session, and all the participants for the presentation. Thanks a lot. And I think this is over the day. Let's call the day and end up the meeting. Neelam, may you please take care of it.
Okay, sir. Okay. Thank you so much, sir. Thank you, sir. Thank you all. They can leave now. Sir, you can all leave.